Good morning, everyone. My name is Parshuram, or Ram for short, and I work as a front-end engineer in Facebook. As a web developer, I've always loved this idea where I could write any content and deliver them across multiple platforms, even across the mobile web using responsive web design. Using technologies like Apache Cordova or PhoneGap, I could pretty much package all of this HTML, CSS, and JavaScript into a native mobile application and also use the device capabilities. No wonder when React Native came around, I was super excited because now I could build upon my existing knowledge and not only create mobile applications, but also make them look like real mobile applications. I'm so excited about the idea of using JavaScript to build mobile applications that almost 1 year ago at this time, during my previous job, I was building tools or developer tools for React Native, things like Code Push, App Center, the VS Code extension for React Native, etc. Fast forward 6 months, I went and joined Facebook, and obviously I landed in the React Native team. When I joined Facebook, I was really amazed by the amount of React Native usage inside Facebook. A majority of the internal apps inside Facebook are written using React Native. There are also tons of external apps that are written using React Native. Typically things like the Ads Manager app that we prominently feature on the React Native website, the Analytics app, and more recently, the companion app to React Native, companion app to Oculus. All of these specifically are greenfield apps or apps that are written from ground up using React Native. There are also other apps like Instagram, which use React Native for a bunch of screens. And of course, the main Facebook app. The main Facebook app actually does use React Native at a lot of places, including features like blood donations, crisis management, etc. React Native is also front and center in the main Facebook app. So this button that you see at the bottom, that's the Marketplace tab, and that is completely written using React Native. And to give you an idea of what that means, this is something that has almost or greater than 800 million daily users, 800 million monthly users. It has more than 100 screens with many developers working across multiple commits and multiple locations. This is probably the biggest React Native application that I've ever worked on. Funny enough, though this is super large scale, the developer workflow is very similar to what typically you would expect. All of the React Native is styled using JSX. It's all CSS pretty much. In fact, we even have a dev server running. We have Metro server running, and as soon as we make changes locally, we just hit Command R, and the familiar loading screen shows up, and then the things just work, or at least most of the time. I mean, I guess you guys get the point, but this definitely is the largest React Native application that I've worked on, and given its scale, there were some really interesting problems that we ran into. Some of the problems that you may not really notice in a typical React Native application. So let me play that video of how I moved from the Facebook app to this screen, but this time a little slowly with an exploded timeline. So effectively what happens is when I start off, I'm on the main page, and then I click the Marketplace tab. As soon as the tab click ends, I see a gray screen, and the reason I see this is because the tab has already changed, but React Native may not have started up. Because this is a hybrid app and because Facebook is a really popular app, we do not want to start the JavaScript PM for every single person. So we start it on demand, and in this case, we just start it when Marketplace loads up. For a very brief interval, you see a gray screen. And once React Native is up and ready, we show the familiar loading screen while we send off the network request. The network comes back, and then we display all the content. So that's where the content starts. Now, though that gray screen shows up only for a very tiny amount of time, that still is a visual jump, and that does not provide for a typical good user experience. Now, if we were to load the contents, let's say 100 milliseconds later, people wouldn't really notice because the network would have already taken 1 second. So they're kind of used to it. But the users who use the app expect instant responses whenever they perform an action. So clicking on the tab should have responded immediately rather than showing them the gray screen. A more familiar or a quicker manifestation of this problem is with something like a set of lists. So in React Native, if you had to write a list view, you typically use a flat list. Now in a case where your flat list is really, really, really big with a lot of content shown on one screen, and if you're able to scroll it really fast, you might come across something like this. So the scroll continues, but for a while you might see this white screen. And then once the white screen is complete, you'll start seeing the views loading up. This happens because React is inherently asynchronous, and through this talk, we will look at what causes this edge case to happen, what are we looking at in terms of fixing these edge cases, and how does this whole architecture, new architecture that we are talking about, how will it help both brownfield apps and greenfield apps, large-scale React Native apps, and regular React Native apps alike. So let's try digging a little deeper into this problem. So how is a flat list really implemented? At the end of the day, it does a bunch of magic. It does virtualization, but effectively what it does is it only renders a subset of the data. So in this case, depending on the scroll position, it will just pick up and render a window of the data. Now, if you're scrolling, say, it will probably show 0 to 10, and then so on and so forth. The key to notice here is the scroll action itself is synchronous. When you scroll on the website, you expect that data or that action to be synchronous. On the other hand, React Native itself is asynchronous. And there is this impedance mismatch that's the primary cause of this problem. Now, we did create React Native asynchronously for a bunch of reasons. And through this talk, we'll look at why both asynchronous and synchronous matter and how does this whole thing work into the new architecture. So let's just take that piece of code and see how React works internally first. I think that way we'll understand how React Native exists today, and then we can look at what the future holds. So this is a super simple React Native component. Effectively, what you do is if you start off rendering that with just one data, on the React side, you get a simple virtual DOM tree. Then if you add one more node there, you would basically be creating one more node on the virtual DOM tree. The thing to notice is the virtual DOM isn't like thrown away and reconstructed. The React reconciliation algorithm takes care of the fact that you have the minimal amount of changes required from going from the old state to the new state. Now, if you were to create a third one, as expected, it would not really throw away the whole thing. It will just rearrange the children. And this is how your code will look like. The question with React, I mean, this is how React DOM and React Native work. The question is, how does this transform, this JavaScript stuff transform to all the things that you see on the Android screen? Now, let's look at that in detail. So as soon as you start your React Native application, you have something called a root view that shows up, and this root view is just the top level holder. And then the React reconciliation happens. So it's basically a tree, a concept that most of us learn only during interviews, but bear with me for a moment. So this is a tree. It's a simple tree, and what happens is it starts at the bottom and starts issuing commands over to the native side. Now this command that you see here on your screen basically is, hey native side, go and create a view for me. The other thing to notice is, though there's only one text element that you may have added on your JavaScript side, that itself might be a composite element. That means that you might be creating yet another element just for that and setting up a hierarchy. So this is typically how the commands for creating a text element work on React Native. Once that happens, the other thing to notice is that number 3 or the number 2 there. So this is a unique identifier that is used to identify nodes on the JavaScript side and nodes on the DOM side. In a more technical sense, it's called the React tag, but effectively that's how all of these unique identifiers are used. So what has happened basically is that it said, hey, go ahead and create a React element with a tag 2 and a tag 3, and then set the child of 3 as 2. Now that it's done with the text node, it goes one level up. And by the way, the other thing to notice is each of these text nodes have, like, both on the JavaScript side and on the native side, they have this React IDs. So now that text node 3 is done, we look at the view node 4. And the view node 4 does a similar thing where it says, hey, go on, create a node for me, and then set the children. And then it keeps going up the hierarchy, and this entire tree structure is created on the native side also. Now, what would it mean when you are inserting another element? So, for example, here you're inserting the text called 3. What's going to happen in that case is very similar. When you insert like a node called 7, it's going to issue the same commands. I'm just running it so that it's a little clearer. Effectively, it creates the same hierarchy, creates the child element, and then The interesting thing to note here is instead of just calling set children, like in the previous case, it calls manage children. The reason why I want to point this out specifically is because this manage children is a command that's very similar to what happens on the React reconciler side. There's like a one-to-one correspondence between the way the virtual DOM is constructed and diffed and to the commands that I issue to the native side. So rather than just setting children, it's actually manage children. Now, you might think that now that we have a native tree, let's go draw this on the UI. That's not entirely true. There are reasons for it, and the tree that you see right now in the native side, it's not what's drawn on the view. It is what is called a shadow tree. So you have a UI thread where that's separate, and this shadow tree helps to draw on the UI thread. The reason why we need 3 threads and we need this structure is because we do not want to keep the UI thread busy. So it's the shadow tree where you take care of all the layouts, and it's on the UI thread. Your UI thread is pretty much empty, and shadow tree does a ton of optimizations so that the UI can be kept as free as possible. Also, whenever you hear people talking about React being multi-threaded or React Native running on multi-threads, these are the 3 threads primarily that people are talking about. So let's go through the exercise one last time. I'm sorry you'll have to bear with the whole tree thing, but let's go through this one last time and figure out what happens when you add the 3rd node. So when you're adding a 3rd node, what I've done on the UI thread part is rather than just showing 0 and 42, I just made it a little more graphical. So on the UI thread, you have like the native hierarchy where you have a bunch of nodes, and I'm now going to go ahead and add a new node on my JavaScript side. So I've rendered a new node. As expected, you will get a bunch of nodes created in the shadow tree. This is very similar to what we saw previously. But the only other difference to notice is because the shadow tree is responsible for layout, all of the CSS properties in that node that you have are passed down to the shadow node. So once this is created, the other thing that happens is it also issues a command to the UI thread and puts an operation in the queue to draw that specific node. Some of you may have already noticed that I did not issue a command for node number 8. I also do not have the green node or node number 4 in my UI thread. The reason for that is because in the shadow tree, it's all about layout, but there is no need to draw the exact tree structure on the UI thread. In fact, the shadow tree DOM optimizes it and tries to figure out which of these are layout only or which of these are virtual nodes. And it does not really go draw the virtual nodes. This way, what's actually drawn is super flattened and super optimized. So let's go ahead and continue our process. There is this hierarchy that is set, and again, the other thing to notice is because there is a hierarchy set and because this is a virtual node, you don't have to go have a corresponding queue operation on the UI part. You just traverse all the way up till you find the real node that you want to draw, in this case node number 1 or the root node, and then you queue that operation. Once that happens, this queue is drained and all of these operations are executed on the UI thread. The queue typically drains using whenever a frame during frame boundaries, and as a web developer you may have noticed how you do request animation frame. This is very similar. The reason why you want to use you want to drain the queue especially during a frame boundaries is because you don't want to interrupt an existing frame, and that way your entire UI doesn't seem janky. So this is yet another reason why you need Shadow DOM. So that way, rather than just sending a bunch of commands over to the UI thread, you're sending it at the right intervals. So this is the overall picture of how React Native works. Let me quickly take a step back here because I know that this is a lot of things going on. There were a lot of arrows and I had to do tons of animation, and Keynote pretty much broke on me multiple times. But just to summarize, in React Native, there are 3 threads. There's a UI thread, which is what you see whenever you're drawing something. This is what is displayed on your device. There's a shadow thread, which is like a separate thread in memory. It's primarily used for layout. The layouting is done using this framework called Yoga. Yoga is React Native's layout framework, and the best way to think about Yoga is you give Yoga a bunch of CSS and flexbox properties, and it will give you the X, Y, height and width of where something should be on the screen. And then finally you have the JavaScript VM, and that's where all of your JavaScript runs. Clear? Okay. So this is what the world is, and once all of this is done, on the JavaScript side, the JavaScript reconciler says, hey, I've done all of this work, I'm finally done, so it issues a command saying, hey, go ahead and dispatch view updates. The reason it does this is because though we have added child number 9, it kind of looks incorrect. I mean, it's not really placed properly, or it's not laid out properly. That's because we haven't done a layout pass, right? So we get this dispatch updates, and this is when the layout pass starts. The layout pass starts from the top of the tree and then goes per child. In this case, it looks at node number 3. It says that, hey, there's no changes, so it can skip that entire subtree. And then it looks at this one, the node number 9, where it says, hey, that's a new node, so I'll mark it as dirty because I need to lay it out. And then it looks at the next child, it marks that also as dirty. And because node number 9 might have to do something, might have changed the position of its siblings, it will mark the entire parent hierarchy as dirty. Now, once that's done, it goes through the rest of the tree, and this is, at the end of the day, this is what my shadow DOM looks like. I have a bunch of nodes that are marked dirty, and all of this information is compressed and taken into a draw command and added to the queue again, just like the same queue that you saw earlier. Once it's added to the queue, the next frame cycle, it runs this queue, and eventually you end up in a world where your screen shows up. So this is pretty much how React Native works, from starting when you write something in JavaScript all the way to the end of the screen. So how does this relate to the problem that we had initially? The problem that we had was this list, right? So how does this list become slow because of this process? I mean, isn't it common knowledge that multi-threaded architecture is usually faster? I mean, yes, that is true. In a lot of cases, using multiple threads is faster, but there are certain cases where going across thread boundaries might be more expensive than the advantages that multi-threading gives us. So if you notice, whenever a scroll happens, you are effectively sending an event from the native side to the JavaScript side. Then in the JavaScript side, you are doing a bunch of operations, which is asynchronous and serialized, and you are changing the shadow tree, which then in turn puts stuff inside the queue, and then the queue is eventually drained to draw stuff. So you do not want to have this back and forth, especially when you're scrolling, or especially when the user is interacting. You want updates to happen almost immediately. So the best thing to look at is, let's look at each part of the system and see where we can optimize. So first, let's look at this layer. So the question is, while this runs on multiple threads, does it really have to run on multiple threads? I mean, does it really have to run on a separate thread? This is threading, and it's perfectly valid for the network case, or it's perfectly valid when you want to render a large chunk of data. But the cost of threading is much higher than the benefits when you want to do immediate updates. So the first change that we are looking at in the new React architecture is a way in which we can pretty much break this thread boundary down. So rather than requiring the shadow tree to run on a separate thread, we are looking at a world where the shadow tree can run on any thread. What that basically means is all high priority updates, like responding to scroll events or responding to button clicks, all of them happen in the same thread as the UI. On the other hand, low priority updates, like getting data from the network, those low priority updates can happen in a separate thread. If you've been following the React architecture, this is similar to what Fiber was built on. And the new architecture that we're looking at derives a lot of this goodness from the Fiber architecture. The trick, however, is now that we have a shadow tree, and now that the shadow tree is going to be running on multiple threads, how do you ensure that it is thread safe? I mean, multi-threaded programming is a pain as it is, and thank goodness we don't have that in JavaScript. But how do you ensure that this shadow tree works well and continues to be consistent when there are multiple threads trying to tell the shadow tree what it should do? One way to achieve that is immutability. So we are working on converting the shadow tree to become immutable. This way, no matter what thread manipulates the shadow tree, the change will always be consistent. Let's look at the second part of the system, which is this one. So if you notice, what we are effectively doing is we are creating a copy of every single node in the JavaScript side. We are serializing it. This is async, and we are creating it on the shadow tree. I mean, is that again really necessary? One way to think of it is in the browsers, when you say document.create element by ID div, the div element that you get, the return of that is not a JavaScript object. It's a native object. It actually holds a reference to the native value. So what is the so though this system of serializing gives us cool benefits like being able to debug on Chrome or being able to run JavaScript on a completely different machine, is it really necessary in terms of performance? The other change that we are looking at is rather than copying the entire virtual DOM over to the shadow tree, why not we hold references similar to what the browser does. So every node in the JavaScript world will now refer to a shadow node. And that is not possible with the current architecture because the way the JSE is structured is it's easier to send queue messages. So we are working on a new interface, a new JavaScript interface between the JavaScript VM and the shadow tree. The side benefit of this JavaScript interface is you will now be able to replace the existing JSC that ships with open source React Native with any version of your own. A lot of people have told us that the current JSC version is very old, and now you'll be able to replace it with V8 or even upgrade the JSC as long as this interface is confirmed to. It's more of an API specification. The other thing to notice is if you look at the shadow tree itself, it's written in Java. The JavaScript VM runs using C++, so it's all JavaScript code that's interpreted by a C++ virtual machine. Yoga also is written in C++. Looking at this diagram, we were not very happy about the language boundaries, so why not convert the shadow tree also to C++? This way, we'll be able to push the language boundary over to as close to the UI as possible, and now that there are three things in C++ talking to each other, it's much easier to share data structures, it's much easier to share nodes and other things across all of these three systems. So in general, this is basically what the new architecture of React Native would look like. The interesting thing is none of the code in the user land should ideally change. All of this will improve not only large scale applications, but also impact or improve existing React Native applications. Now, here's another example of how this entire new architecture will improve a problem or will improve a bug that has been sitting in the open source GitHub repository. So there's this bug number 20119 on GitHub issues, which says that text input becomes slow. So the bug, you may not be able to see it, but at the top there's a dropped frame count, and as you start typing more and more and more things, the text input kind of becomes slow. If you investigate why that happens, here's the structure. So let's say you have this text input and you type something like, and here's the text input's definition. I mean, this is nothing fancy, it just says whatever I type, I set the state. So it's effectively a controlled component. So here, if you type something, say R, what's going to happen is a message is going to be sent saying the text has changed, and it'll say, hey, on text change R. Then what's going to happen is the state is going to get set, and then because the because I say value equals this dot state dot text, I'm going to send back a message saying, hey, can you set this back to, can you set the value to R? But what can happen is before this back and forth happens asynchronously, I could be super fast and could have typed a second character here. Now that I've typed E, this also gets queued, and it says, hey, by the way, I've already typed E, so can you now change the state from R to RE? Now that happens, and the second instruction is also queued. And remember, we already had the first instruction that was queued, so we send that over, and the E that you see on the screen will go away because React Native is now telling your device, hey, the value there should not be RE, it should be R. So the E will disappear, it will become just R, and then the next instruction will come over and it will make it RE. Now this is not very ideal, and the way we kind of work around it is we add a debounce function. So we have a debounce of 100 milliseconds inside the text input code right now. That's not the most ideal, but this happens because of the whole asynchronous nature. And in this case, the user is typing really, really fast, probably in cases where they have like a physical keyboard connected or something like that. Now, if this was to look, the question is, how would this look in the new world? In the new world, you type in R, the operation to change the text will happen, but because this can now be a high priority update, this can be synchronous. This is synchronous, so you'll immediately send the message back to type in R. When you type in E, the whole thing happens again. So this is how not just scroll views, but a whole bunch of other edge cases that we are now dealing with will be fixed. Let me give you another case. You have an existing native application. A lot of people you here have, when I spoke to a lot of people here, they did tell us that they have an existing application and they want to add React Native into it. So today, if you try to do that, this is like a native list, for example. It's a UI view, or it's like a recycler view or something like that. And if you want to add React Native today, there's no simple way to add React Native into this native view. That's because React Native layout is asynchronous. So you don't really know what the height of the React Native view is. So what typically ends up happening is it gets added with 0 height. And we currently have workarounds, at least in iOS, where we say instead of using root view, use RCT surface view. But in the new world, if the layout itself is synchronous, you don't have to go through all these tricks. You would effectively be able to add the view, and all of the layout happens synchronously. So to summarize, I think these changes, I'm actually really excited about these changes. This gives me the ability to run React Native in both synchronous and asynchronous mode. It actually lets me run my high priority updates or respond to user events in a synchronous manner while continuing to do like network and all of these in an asynchronous manner. I'm pretty excited about React Native and the long-term roadmap that we are looking at. This is a long-term project, so this is not something that we are going to drop immediately. And I'm glad that we are working on this because this will improve both existing React Native apps and brownfield React Native apps without having to have much changes in the userland code. That's all I had. I know that these slides were a little bit dense, so if you have any questions, we would love to answer you. We have members from the React Native core team here at the conference wearing the Facebook t-shirt. Please do come talk to us. We are here to help you. My DMs on Twitter are also open, so either send me an email if you have specific questions or want to know more about it. Thank you.